Section 7.4 concerns double angle and half angle identities. These are your double angle identities. You need to put these on your sheet, so you could pause the video and add those to your sheet, and then you're going to be using those. So pause, put it to the sheet, and then we'll go on. Here's an example of how you're going to use those. Let's say that they give you that you have the sine of sine of theta is 2 over 3, and that theta has its terminal side in the first quadrant. You're going to find the exact values of several of these. So if you look at the sine of 2 theta, you don't have a whole lot of choice there. So the formula that you're using, or the identity that you're using, is this identity. Now, that's going to require me to find out what the cosine of theta is. I know what the sine is, so I'm going to draw my triangle. Here's theta. The sine is 2 over 3, or opposite over hypotenuse. And by Pythagorean theorem, you're going to find that adjacent is the square root of 5. So the sine of theta is 2/3. The cosine of theta is going to be the square root of 5 over 3. Then I just have to plug them in. So 2 times 2/3 times the square root of 5 over 3 is going to give me 4 on the square root of 5 over 9. And that's going to be what the value of the sine of 2 theta is. Then you're going to do the same thing with the cosine of 2 theta. Now, you've got the sines and you've got the cosines already, so you could use any of those theorems. You know that there's several. I'm going to choose the one that just has the sine in it. So 1 minus 2 times the sine of 2 theta is one of your double angle identities. So I put in here 1 minus 2. The value of the sine is going to be 2 over 3, so I'm going to square it, and I'm going to make it 4 over 9. So I have 1 minus 8 over 9. This, of course, translates to 9 over 9, so I get a value of 1/9. That is the value of the cosine of 2 theta. Now, you're going to come back and you're going to need those again in a minute. Okay, then I have the tangent of 2 theta. Now, you remember the identity that goes with that is going to be 2 times the tangent of theta over 1 minus the tangent squared theta. Well, go back to your triangle that you drew. If I'm here, the tangent is opposite over adjacent, which is 2 over the square root of 5. So the tangent is 2 over the square root of 5, or 2 on the square root of 5 over 5. Okay, so that's what I'm going to use here. So I have 2 times 2 on the square root of 5 over 5 divided by 1 minus, and if I square this, I don't have to worry about where I rationalize it. It's going to give me a 4 over 5. So that's what I have right there. So you know that that's going to be 5 over 5 minus 4, or 1/5. So you're dividing 4 on the square root of 5 over 5 by 1/5. So you're going to invert and multiply. The 5s are going to cancel out once you flip this, and you're going to get 4 on the square root of 5. This one, you are going to use some of the answers for what you've already done. I'm going to look at it as the cosine of 2 times 2 theta. So this is going to be my angle. So that's the same thing as saying the cosine squared of 2 theta minus the sine squared of 2 theta. Now, I already know what the cosine of 2 theta is and the sine of 2 theta based on what I've already done. So here, I know that the cosine of 2 theta is 1/9, okay? Coming from that spot right there. So 1 over 9, and I'm going to square it. And then I'm going to do the same thing. I find out where the sine is, if you will, 4. The sine squared is, or the sine of 2 theta is 4 on the square root of 5 over 9, and I'm going to square that. So that's going to give me my answer when I do that. So I'm going to get 1 over 81 minus, and this is going to be 16 times 5, which is going to be 80. When I square my 9, I get a 81, so this is going to give me a negative 79 over 81. So that is the value of the cosine of 4 theta. All right, let's do another one. Okay, this, I know that the sine is 3/4, so I want to draw my angle so that I can figure out the cosine. So 3 over 4 is going to give me that. So when I work backwards, I'm going to find out that this side, using Pythagorean theorem, that side is the square root of 7. So therefore I know that the cosine of theta is equal to the square root of 7 over 4. So, and I'm going to have to switch, I'm running out of lead here. Switch to a pen. Okay, so I've got 2 times the sine of theta times the cosine of theta, because that is the identity for the double angle of the sine. So I have 2 times 3/4 times the square root of 7 over 4. This is the sine of theta, this is the cosine. Sine, cosine. So that's going to give me 6 on the square root of 7 over 16, but I can reduce that down to 3 on the square root of 7 over 8. Now notice it's first quadrant, so I don't have to worry about positives and negatives. If that was different, then I might have different SIGNs here. Okay, double angle, 1 minus 2 times the sine squared theta. So I have 1 minus 2 times, the sine is 3/4, so when I square it, I've got 3/4 squared. So 1 minus 2 times 9 over 16. So I've got 1 minus 18 over 16, which is going to give me a negative 2 over 16, which is equal to a negative 1/8. So that's my value of the cosine of 2 theta. Okay, now I want to go on to the tangent of 2 theta. So I go back to my triangle. Remember, tangent is opposite over adjacent, so the tangent of theta is equal to 3 over the square root of 7, or 3 on the square root of 7 over 7. Okay, so I use my equation, or my identity, 2 times the tangent of theta over 1 minus the tangent squared theta. So I have 2 times 3 on the square root of 7 over 7 over 1 minus, and if you square this part, you're going to get 9/7 right there. So now I have 6 on the square root of 7 over 7 divided by, this would be 7 over 7 minus 9 over 7, so divided by a negative 2/7. I'm going to flip it, and I'm going to end up with 6 on the square root of 7 over negative 2, which is going to give me a negative 3 on the square root of 7, which is my answer to the tangent of 2 theta. All right, remember on this one, I've got to go back and use the answers to my cosine of 2 theta and my sine of 2 theta, because now my angle is 2 theta. Okay, my cosine of 2 theta was negative 1/8, so I'm going to square that because I've got the square there. My sine of 2 theta was 3 on the square root of 7. I think it was over 8, let's see. Yeah, over 8 squared. So this is going to be a positive 1/64 minus, that's going to give me 9 times 7, no, yeah, that would be, when I square that 3, it's going to be a 9 times 7, so it's going to be a 63 over 64, which is going to give me a negative 62 over 64. I'm looking, did I put that down right? I think I did. Yeah. Okay. So when I reduce that down, it's going to give me a negative 31 over 32. Okay. All right. Then these are more identities that you need to put on your sheet. So again, pause it again and make sure that you add that to your sheet. And now we're going to use those. Okay. First thing I would do, if they give it to you in radians, I would go ahead and change it to degrees because it's easier to see. So I have pi on the bottom, I have 180 on the top, and that's going to give me 105 degrees. So technically I'm looking for the sign of 105, but that is not on my unit circle. I do know that that is in my second quadrant, so the value is going to be positive. So if you go back here, you're looking at sign. I know I'm going to choose plus here because the sign is positive in the second quadrant. So I can look at that as the sine of 210 divided by 2. So that is going to equal to the square root of 1 minus the cosine of 210 divided by 2. So that's going to give me the square root of the cosine at 210 is a negative square root of 3 over 2. So 1 minus negative square root of 3 over 2 over 2. So if I write this sideways, I have a common denominator here is 2. So I have 2 plus the square root of 3 over 2. I can say divided by 2 over 1, so I'm going to flip this and I'm going to end up with 2 plus the square root of 3 over 4. Well, I know it's positive because the sign is positive in the second quadrant. Notice I can take the square root of 1 on the bottom, so here's what I'm left with. Now that looks weird because you have a square within a square root within a square, but that is the actual correct answer. Okay, let's do another one. This one is in degrees, so I don't have to change it, but I do know that the cosine of 67.5 is first quadrant, so I know this is going to be positive. I can write this as the cosine of 135 divided by 2. So that's equal to the square root, again I know it's positive because it's the first quadrant, of 1 plus the cosine of 135 divided by 2. So that's going to equal 1 plus square root of 2 over 2, because that's the cosine of 135 divided by 2. So that's going to give me a 2 plus the square root of 2 over 2 when I make a common denominator up here, divided by 2 over 1. So I'm going to invert and multiply, which is going to give me 2 plus the square root of 2 over 4. Again, I can take the square root of 4, so I'm left with, wait a minute, I'm not sure I finished that. Oh, I didn't put the 2 on the bottom here. You got to have the 2 on the bottom because that's the square root of 4. This is 2 plus the square root of 2 over 2, and that's going to be your answer. Okay, let's do a couple more. If you're looking at cosine of pi over 8, you're going to again change it to degrees, or at least I would. So you have 180 over 8, which is equal to 22.5. So I'm looking for the cosine of 22.5, but again, that's not on your coordinate plane, or not on your unit circle. So I can look at that as the cosine of 45 degrees divided by 2. Now, 22.5 again is in the first quadrant, so it's going to be positive. So I've got the square root of 1 plus the cosine of 45 divided by 2. So I've got the square root of 1 plus the square root of 2 over 2 divided by 2. Okay, this is going to give you common denominator, 2 plus the square root of 2 over 2 times 1 over 2, because I'm going to keep change flip. So I have the square root of 2 plus the square root of 2 plus the square root of 2 over 4. So that's going to give me the square root of 2 plus the square root of 2 over 2. Okay, tangent, again, that's going to be in the first quadrant, so I know it's going to be plus in front of it. Now, that's the same thing as saying the tangent of 30 divided by 2. So based on my equation, I have a 1 minus the cosine of 30 over a 1 plus the cosine of 30. Let me double check, but I think that's correct. Yeah, okay. So I've got to work this thing out. This one's a little bit more complicated because of the top and the bottom. So the whole thing stays underneath the square root. So this is 1 minus the square root of 3 over 2. And this one is 1 plus the square root of 3 over 2. So when I work this thing out, let me come back over here. I've got to change this to 2 over 2. So I have the square root of 2 minus the square root of 3 over 2 divided by 2 plus the square root of 3 over 2 when I do a common denominator there. So I'm going to keep change flip. So I have the square root of 2 minus the square root of 3 over 2 plus the square root of 3. This whole thing is underneath the square root, so I'm going to multiply the top and the bottom by 2 minus the square root of 3 and 2 minus the square root of 3. That's going to give me on the top, it's going to give me a 4 minus 4 on the square root of 3 plus 3 over on the bottom. I'm going to have a 4 minus 1, okay, because that's going to be first and last. No, 4 minus 3, I'm sorry. 4 minus 3, so that's going to give me a 7 minus, and this is still underneath the square root, 7 minus 4 on the square root of 3 over 1, because the square root of 1 is 1. So I could write it like this. All right, then you have identities that you're going to verify just like you did in the other problems, but this time you can add the double angle and the half angle here. So I think what we're going to do is we're going to work on the right hand side. So I've got the cosine of theta over the sine of theta minus 1 over the cosine of theta sine of theta plus 1. I've got to write these with a common denominator, so when I do that I have the cosine of theta. This is going to be sine over sine, so minus sine of theta over the sine. That's what that becomes. Divided by, now I'll do the bottom one, so I have the cosine of theta plus the sine of theta over the sine of theta. That's what this changes to. I'm going to keep change flip. I'm going to get the cosine of theta minus the sine of theta over the cosine of theta plus the sine of theta. Now, if you go and you look, I want that to be the cosine of 2 theta. Well, one of the identities of that, if I flip back here, let me see if I can find it real quick. Okay, you see one of these is this one. So I want to work backwards. I want to multiply this. I can do the difference of squares and come up with that cosine squared theta minus the sine squared theta. So if I multiply the top and the bottom here by the cosine squared theta plus the sine squared theta, and it's legal as long as I do it to the top and the bottom, because then it's like multiplying by 1. So on the top, this is the difference of squares. Whoops. I don't mean to square it. Okay, so that's going to give me cosine squared theta minus sine squared theta, which is what that's equal to. So the top part I've gotten. The bottom part, I'm going to have to do FOIL on it. So I have the cosine squared theta plus 2 times the sine of theta cosine of theta plus the sine squared theta. This plus this is equal to 1, so that gives me the cosine squared theta minus the sine squared theta over 1 plus 2 times the sine of theta cosine of theta. Okay, coming over here, so on the top, that gives me the cosine of 2 theta. If you look at your identities, you see that this part right here is equal to the sine of 2 theta. So that is exactly what you were trying to get. Okay? All right, one more. Let's work on the left side. I think that's more complicated. So I'm going to take this, thinking about the fact that I want to end up with a sine over the cosine. This is the same as, hold on, let's do that like this. Hold on. That's the same as 1 over the cosine squared theta. Okay, now knowing that I want to get tangent squared theta, I want a sine on the top. So I think what I'm going to do is I'm going to take the identity that looks like this, cosine squared theta minus sine squared theta is equal to that. The problem is you have several to choose from, and you could have chosen a different one. This is just the one that I used. So I have, if you will, 1 minus, and I'm going to distribute this. So I have the cosine squared theta minus sine squared theta over cosine squared theta. Okay, if I want a common denominator here, now remember I'm going to have to distribute that negative here. So I can go cosine of theta, cosine squared theta, because that's my common denominator. I make this into cosine squared theta over cosine squared theta minus cosine squared theta, distribute my minus, plus sine squared theta over cosine squared theta. This minus this equals 0. So what I'm left with is the sine squared theta over the cosine squared theta, which you know is the tangent squared theta. So therefore I have proved this. All right, your homework on this, and just give it a try. Page 454, 14 through 34 even.